Hi everyone, today we're going to be talking about factoring. We're going to talk about factoring simple trinomials, factoring differences of squares, and factoring perfect square trinomials. Okay, go ahead and grab a piece of paper and a pencil, and let's get started. So the first thing we should talk about is, well, what is a simple trinomial? So a simple trinomial basically means we have a 1 in front of our x squared term. So again, if there's no number or coefficient in front of the x squared, a 1 is understood to be there. So what we're going to do is we're going to look for two numbers that add to give the middle term and multiply to give the last term. And this is how we're going to factor. Okay, so again, we're looking for two numbers that add to give the middle term and multiply to give the last term. Okay, so our first example is factor x squared plus 12x plus 32. So we're looking for two numbers that add to 12 and multiply to give 32. Okay, go ahead and think about your factors. Okay, hopefully you figured out that 8 and 4 add to 12, and 8 and 4 also multiply to 32. So now we're going to put it all together into two brackets. So we know because it's a simple trinomial, at the beginning of each bracket we're going to have an x. So let's go ahead and fill that in. And then the other part inside the bracket are those two terms. So because our 8 and 4 are both positive, we're going to have x plus 8 and x plus 4. It wouldn't have mattered if I reversed numbers and had x plus 4 and x plus 8. Either will work. Okay, let's look at a second example. Factor x squared plus 5x subtract 14. Go ahead and find your two numbers that add to give 5 and multiply to give negative 14. Okay, did you figure out your numbers were 7 and negative 2? Great job. Okay, so again, we're going to put those into our two brackets with an x at the beginning of each bracket. So we have x plus 7 in one bracket and x subtract 2 in the other bracket. And remember, you could always check by expanding and simplifying, either using FOIL or using a chart method. So x times x is x squared, x times negative 2 is negative 2x, 7 times x is 7x, 7 times negative 2 is negative 14, and when we combine our middle terms, we end up with x squared plus 5x minus 14. Okay, here's our next example. All right, factor x squared, subtract 3x, subtract 10. So again, you're finding two numbers that add to negative 3 and multiply to negative 10. Go ahead. Okay, so the numbers that work are negative 5 and positive 2. Okay, so let's go ahead and put that into our two brackets. So x subtract 5 in one bracket and x plus 2 in the other bracket. All right, next example. So now we're going to look at factoring something called perfect squares. So before we go ahead and factor perfect squares, first we need to recall, well, what are perfect squares? So go ahead and make a list of squares from 1 to 10. So for example, 1 squared equals 1, 2 squared equals 4, and so on. Go ahead. Okay, so as you continue your list, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, 6 squared equals 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, and 10 squared is 100. Of course, our list can continue and you could keep going, but in the interest of time, we'll stop there. Okay, so we're going to factor x squared subtract 100. So notice that there is no middle term with an x. So we could have written this as x squared plus 0x subtract 100, but I don't really need to write the 0x because anything times 0 is just 0. But you do need to know that the middle term has to add to give 0. So we are looking for two numbers that add to 0 and multiply to give negative 100. Okay, go ahead and think about those factors. Okay, so our factors are negative 10 and positive 10. So if I add negative 10 and positive 10 together, we're going to get 0. And if I multiply them together, we get negative 100. So inside my brackets, I'm going to have x minus 10 and x plus 10. So one thing that I want to point out as well is the word differences. So differences mean that we have that subtract sign in between our two terms there. And squares basically means our last term is a perfect square. Okay, let's take a look at another example. This next one, we have a term in front of the x squared. So we have 4x squared subtract 64. So what we can do here is we can common factor the 4 from each term, and then we can look to see what the result is and see if we can factor further. So the greatest common factor would be 4. So if I factor out the greatest common factor of 4, we're left with 4 times x squared minus 16. So if I look inside those brackets, that's actually a differences of squares question. So we can factor x squared minus 16. So we're looking for two numbers that add to give 0 and multiply to give negative 16. Go ahead and find your numbers. Okay, hopefully you found your numbers were negative 4 and positive 4. So now we're going to put it all together. So we're going to write our final answer as 4, so don't forget to put that GCF out front, because otherwise if we forget the GCF, if we were to check by expanding and simplifying, we would not end up with 4x squared subtract 64. So in our first bracket, we're going to have x minus 4, and in the second bracket, we're going to have x plus 4. Okay, that's it. Great job. Let's look at the next example. So the next example is x squared plus 25. So we're trying to find two numbers that add to give 0 and multiply to give 25. Go ahead. Did anybody notice that instead of a subtract in the middle, we have a plus? So that was actually a trick question. So we can't actually take the factor or the differences of squares of x squared plus 25. First of all, there's no common factor. And second of all, there are no two numbers that multiply to give 25 but add to give 0. So this was a trick question. It's not possible. So not possible because it's not a difference of squares. All right, here's your next one. So these are actually called perfect square trinomials. So we're going to find two numbers that add to give 18 and multiply to give 81. So go ahead and find your numbers. Did you figure out your numbers were 9 and 9? Okay, let's go ahead and write out our factors. So in the first bracket, we have x plus 9. And in the second bracket, we have x plus 9. So because our two brackets are the same and we have x plus 9 and x plus 9, we can actually write this as a single bracket squared. So I'm going to rewrite this as x plus 9 in brackets all squared. And that is how you factor a perfect square trinomial. We just have a couple more examples and then we'll be done. Okay, so go ahead and factor x squared plus 12x plus 36. So you're looking for two numbers that add to give 12, multiplied to 36. Go ahead. So did you find your numbers were 6 and 6? Great job. So let's go ahead and write our factors. So x plus 6 and x plus 6. So remember, because we have the same bracket written out twice, we can write it as x plus 6 all squared. All right, last question. This question, again, is a factoring perfect square trinomials. However, notice that there is a 3 in front of the x squared. So what do you think we're going to have to do first? So always check to see if there's a greatest common factor. So can I divide 3 out by each of those terms? Yes, I can. So go ahead and first factor out your GCF of 3, and then we'll probably be left with a perfect square trinomial. Go ahead. Okay, so once you factored out your GCF of 3, the result inside the brackets is x squared plus 14x plus 49. So that bracket does in fact have a perfect square trinomial. So the numbers that add to 14 and multiply to give 49 are 7 and 7. So we're going to write our final answer as 3. So again, don't forget your GCF in front of your bracket. Then x plus 7, x plus 7. And again, I can write that as 3 times x plus 7 squared. All right, great job, everyone. That's it for today. Bye-bye.